So this is a continuation of section 4.3. We're looking at the properties of logarithms. So right now what's going to happen is we're going to take a logarithmic expression and write it as a single logarithm. So essentially we're using those properties we saw in part 1 in reverse. In part 1, we expanded. Now we're condensing. So we're going to write the logarithmic expression as a single logarithm with a coefficient of 1 and simplify as much as possible. So the first one, we have log of 4x minus 3 minus log of x. That subtraction right there indicates that we're going to turn that into a quotient. So we would rewrite this as log of 4x minus 3 over x. We have a single log with a coefficient of 1. The phrase coefficient of 1 means that if there was a power in front of it, we would, if there was a coefficient in front of it, we would move it to be a power. Okay, so in number 16 right here, we have log base 2 of z plus 4 log base 2 of y. So our single log is going to be, we're going to combine those as a product because those two things are summed, and then we're going to use the power rule to move that 4 to be an exponent of the fourth power on y. So our final result for this one would be log base 2 of z times y to the fourth. Okay. So number 17, we have 3 natural log of x plus natural log of x minus 2 minus natural log of 5. So here, this means we have the product of these two and then the quotient with this one. So in my natural log, I'm going to have in my denominator 5. The numerator, for the first term, we're going to have an x to the third power, because that power rule is going to change that coefficient to a power of 3. And then my second term is going to be that x minus 2 in the numerator. Now, I could rewrite this. Now, it might be sufficient to have it written this way, but I could rewrite this as the natural log of x to the fourth minus 2x to the third over 5. I would accept either one of those on a test, but if your homework is very sensitive, you might want to rewrite it like this. This last one is a doozy. We have here a power applied to both of these terms, okay? Then we have a power that's going to be applied to this term, and that value within the log. And then we have a quotient. We're going to end up with powers and quotients and products, and we're going to end up with a lot of simplification that happens on this last one. So let's take a look, see what happens. First thing I'm going to do is I'm going to rewrite this natural log of x minus natural log of x squared as the natural log of x over x squared, which is the same thing because these would cancel as 1 over x. Then to that, I'm going to apply this power of 2, okay? So I'm going to end up with that first term as being the natural log of 1 over x squared. The second piece right here is going to be the natural log of z to the 9 times 2/3 power. But that cancels out to give me z to the 6th. And then that's going to be divided by, because of this subtraction here, by z. Z to the 6th divided by z gives me the natural log of z to the 5th. So if I'm doing the product of those two things, then, or the sum of those two things, then that's going to end up being the product. So when I multiply those together, I'm going to end up with the natural log of z to the 5th over x squared. That one is quite a doozy. If you have any questions, make sure you stop in the Blackboard Collaborate to ask, or email me and let me know what's giving you trouble with it. So this next part is applying the change of base formula. This change of base formula is incredibly important. One of the reasons why it's super important is because if you take a look at your scientific calculator, there are only two log buttons, a log and a ln, natural log. So it defaults to base 10 and base e. And because of that, when we have something that's a different base, we have to calculate it using the change of base formula. So if I have a and b are positive real numbers, such as a does not equal 1 and b does not equal 1, for all positive other real numbers, we get log base b of x is going to equal log base a of x over log of base a of b. So that's a really fancy way of saying that I can rewrite something that has a different base other than 1, e, or 10 in terms of the log of that value, base 10, over the log of the original base. Or I can also do the natural log of that value divided by the natural log of the base. Also, you might want to check on these examples that you get the same result for each one. So let's see, we're going to use a calculator to approximate these, and we're going to round our final answer to 4 decimal places. So if I have log base 7 of 15, in my calculator, I would put log of 15 over log of 7. When I do that, in my scientific calculator, I'm going to end up getting approximately, I'm going to write it up here, 1.39166, etc. But they told me to round to the nearest fourth decimal place, which is my 10,000ths. So that's going to be approximately 1.3917. That rounds up. Please make sure that you're rounding properly. If you keep getting something wrong on your homework, it might be the rounding. So one thing I want you to do is check and see if I had done natural log of 15 divided by natural log of 7, what would I have gotten? Okay, so on this next one, we're going to do log base 5 of 0.3. So I'm going to do log of 0.3 divided by log of 5. When I do that and calculate it in the scientific calculator, we're going to get negative 0.74807, ... It goes on. Okay. So I'm rounding to the fourth decimal place. That gives me negative 0.7481. So using the change of base formula is not difficult. It's extraordinarily helpful. And anytime you need to actually calculate a log, it's a good thing to know and make sure that you have down and have practiced many, many, many times. The last thing I'm going to go over is, I think, one of the trickiest problems from your homework, and that's just because of the way that it's worded. It'll say something like, let log base b of 8 equal z and log base b of 7 equal k. Write the expression in terms of z and or k, and then they give you an expression like this, log base b of 49. So what they're trying to get you to see here is that log base b of 49 is the same thing as log base b of 7 squared. By the power property that we saw in the beginning, that's the same thing as 2 log base b of 7. And they told us that log base b of 7 is equivalent to k. So I can actually take this entire thing and replace it with a k. So your final result in this case would be 2 times k. So when I first saw this when looking through y'all's homework, I was like, that's a little tricky, and the normal content doesn't really address it, so I wanted to make sure I went through an example for that. Please make sure that you complete the 4.3 homework by the deadline and attend the Blackboard Collaborate sessions if you have questions. If you also have questions, you can email me or reach out to me and I will get back to you. I hope you are staying healthy and safe. Talk to you soon.